Yes. All right, we're recording. So
Okay.
something was lost. Go ahead.
So this is ground level, and the first thing, everybody's in the International Space Station because you see the videos taken there, and everywhere is flying. So you're saying there's zero gravity over there.
Right.
No, there is no zero gravity. It's very close to the Earth, but it is orbiting so fast
Yes.
that the gravity is contrasted, countered by the centrifugal forces.
Yes.
So it's like zero gravity, but
Right. So it's not
very close
actual-
to the Earth.
Okay.
Planes, passenger planes, domestic flights, flight over here, and International Space Station it is here, and comets, meteorites. No comets. Meteorites burn over here, very close to the ground level. They are burned.
Understood.
GPS satellites
Yes.
orbit in this line. These are GPS. All our cars, when we use the GPS and when we use Google Maps, they are based on signals from these satellites.
Yes.
And this other line is from geostationary satellites.
Geostationary satellites.
Geostationary satellites. They are used for military purposes, and they spy on us.
Understood. Yes. That is what they do. Yes. Understood.
They are midway from the moon, to the Earth, midway.
Yes.
Then there's these satellites that are for scientific purposes. That this is WMAP, and this is SOHO from the Chinese space agency.
Okay.
Then we go to the planets. The closest planet to the Earth is Venus.
Yes.
This is the closest,
Okay.
and then this is Mars and Mercury, the Sun. Then it is the asteroid belt,
The asteroid belt. Okay.
and then this Jupiter, Saturn, Uranus, Neptune.
Yes.
This is the Kuiper belt. Pluton is one of these rocks. It is not longer considered a planet
Yes. They declassified
because
it.
there
Yes.
are a lot of rocks that are the same size as Pluto.
Okay.
So maybe here's Pluto, and this is Ceres, and there are a lot of small planets. I think they are called now. Here is a proof that was launched in the 70s that is called from NASA, and it's called Voyager.
Yes.
Voyager
Yes.
2.
Voyager. Okay.
Around here it would be Voyager 1 that it was launched 2 years early, and around here would be Pioneer 10 that it was launched 5 years earlier,
Okay.
on the 70s. This whole thing is a sphere that surrounds the solar system with of rocks of ice. No, ice pieces that it's like a sphere, like they make around the whole solar system,
Right.
and there are a big amount of ice.
Okay. Now, what is this?
This is a star that it is
star, okay.
a background.
Got it. Okay.
All that the stars are background but are not closer to the they are not close to the Earth. And here we have the closest star from the Earth. This system is a binary system of two stars. This is Alpha Centauri and Proxima Centauri.
Alpha
They are
Centauri.
the closest star from the Earth. And then we have the solar closer neighborhood of stars.
Yes.
This is Sirius. Sirius that is
Okay.
blue.
Yes. Okay.
There
that's
are
Sirius.
red giants, red dwarf,
We're dwarfs. Okay.
brown dwarfs. They are called. They are like a bit like Jupiter.
Okay.
And this whole swarm of stars make the arm that is the arm of the Milky Way that is called the
arm of the Milky Way,
Perseus
yes.
Perseus arm.
Okay.
The Milky Way is, now we know that it has a bar in the middle. Before we thought that it was just a center, that it was a sphere, but now we know that it has a bar in the middle,
That's that solid area there, right?
and it has all these arms and these clouds of dust that we see in the night. That is a darker cloud.
Yes.
This is dust that covers a lot of stars that are behind that, but it's darker.
Okay.
This thing over here is the sister galaxy of Milky Way.
Yes.
It's called Andromeda.
The Andromeda. Yes.
The Andromeda galaxy. It's these two galaxies are the biggest of the local neighborhood of galaxies,
Yes.
and these other galaxies are farther away.
Right.
All the galaxies, when we look at the bigger scale, they form these little threads. They are arranged in these threads, like they are forming like a network or like a sponge texture.
Okay.
And if we look at from very far, they get so dilute that they are like an uniform structure, and they don't seem to have a structure that is like noise.
Okay.
This is called the end of greatness.
The end of
The end of
okay.
greatness, el fin de la grandeza. That is because you can recognize any structure here.
We will clean it, I promise. We will clean it.
Little dirt.
We will clean it.
So the end of greatness is that to say that the universe is very uniform on the big scale.
Yes.
Then we think that we see that these galaxies are white,
Yes.
and then are yellow, and then are orange and red,
Yes.
because this picture is made from the perspective of what we see from Earth,
Right.
and these galaxies are so far away, and like as the universe is expanding, the expansion of the universe also expands the wavelength of the light from things that we are seeing, and these are so far away that they have expanded a lot the space between them. So the wavelength is also expanding, and we see it more redder, more red.
Yes.
Over here we don't see, we only see quasars, because the first thing that was created on the universe, they were called quasars, and they are. We don't really know what quasars are, but we think that they are baby galaxies, the galaxies in their stars, and
the beginning of new galaxies.
The beginning of new galaxies, and that's what we see here: baby galaxies, and then we don't see anything else. We think that it is because there is nothing else to see, because matter didn't accumulate in big structures. It was all diluted at the beginning of the universe, and then we see this thing on the background of all. It's called the background microwave background radiation, and it's very red because it's the most far thing we could see, and it is the first light that shone when the universe became transparent, because from here to there the universe was so dense and so compact that there was no space from light to flow.
When included.
There was no space from light to flow.
Yes.
From here, it was a single moment when the universe became transparent.
Okay.
And it flashed like a white light, because all that light was compressed and waited to shine, and suddenly it became transparent and it shined. It was light, it was white, but so much space and time has been between this and Earth, so
right.
that we now see it infrared.
Right.
We see it more stretched than red.
Okay.
And this thing over here,
yes.
it's pictured in gray color.
Yes.
For us to picture it, but it was it is invisible. It is like the plasma of the Big Bang.
Okay. So that you've depicted it there so that we can see it,
So
but
that we can see it.
we would not otherwise see it.
Here for us to see it, but it is really black because there is no space.
There's no light there.
An eye to see it, or a photon to flow.
Right.
There is no space. There's a big compressed matter and energy here.
Okay.
So the scientists, they are making all those math and taking. If this was here and it's traveling over there, maybe before it was here, and if before it was here, and they are doing all those math, and they think that if the universe is expanding at the rate it is expanding today, with the inflation that was at the beginning and with all the things that are considered, they think that the Big Bang should have happened just here, and this is 13 billion years from now.
Wow.
In the past.
Right. Okay.
So that is the whole picture.
Now, what inspired that, though? I mean, what you said it was for your son's birthday party, but for the guests. But what?
Yes.
Why this versus something else?
Because I was making something that I needed to be circular for some paper things that I call hexaflexagons,
Okay.
and I think okay, it has to be something circular, and it has to be have six objects around. I think that I'm going to put the sun on the middle, and maybe six planets around. And then thought, okay, I can make the universe picture.
Make it bigger, but
Make it
show
bigger.
more. Yes.
So I started drawing one night, and then I imagine do it something like this.
Thank you for sharing that. That's awesome.
Did you always have an interest in astronomy before you drew the picture?
Yes, yeah, a lot, yeah. I'm a musician and composer, and at first I was writing about songs about my life, about what happened to me, and then I was thinking about, okay, everybody writes about that, but what about writing something about something more spiritual or more
Universal, or is that the right
universal,
word?
elevated than that? And then I thought, okay, let's write some poetry that is inspired on the cosmos, on all that. And well, I have always been obsessed about this kind of thing.
Sure. That's awesome.
If you want, I
Yes,
show you
please.
something.
Please, yes.
What is?
Do you want to come back, or do you want to start it which way?
Okay, we can
Okay.
over here. Is these two things are very related because these things are layers
Yes.
of orders of magnitude or scales of the universe.
Okay.
This is the biggest scale. We don't know how the universe is big. Maybe it's infinite. We know that it's bigger than we can see.
Sure.
Because if it were smaller, we couldn't see the microwave cosmic background.
Yes. Okay.
So we know that the universe is. I'm sorry, I'm going to tell all the measures in meters. And
I learned the metric system. I'm fine with the metric system.
Okay.
We'll translate it for anyone who doesn't know.
It is like 10 to the
27
27 meters.
meters. Okay.
That is the smallest measure possible for the universe, but I think that it's over 17 times bigger or more. Or maybe it's infinite. We don't know. We
Sure.
think it should be infinite because the universe haven't shown to be curved. It have shown to be flat. If it were curved, we would know that it's like a 4D sphere,
Yes.
and we know that if we are coming over here, then we can get over here, or we're coming over here, we can get over here. But we don't think that is possible with the actual test that we have made, because it seems to be very flat. So maybe it's infinite. And this is the observable universe. This is the thing we can observe. Only have here is Earth, and from the 13 billion years that the universe has, we can observe it to here, and we can we cannot observe further than there.
Okay.
But if we zoom this out, we can watch that the structure is like this web. It's like a spider web, and the galaxies arrange in filaments and in walls. There are great walls. This is huge, but they are arranged in little threads. They are not little, they are huge, but they are threads.
Right.
And if we zoom in, these threads are made of galactic clusters. Each one of these points is a galaxy. And if you zoom out, they are a thread, but if you
Yeah.
zoom in, they are like this, a cluster, big cluster, and they are form a thread.
They form a thread
They
together.
form a thread, but they are cluster.
Okay.
If we zoom out, if we zoom in, we can now see the structure of each galaxy. Some of them are elliptical. We say they are called elliptical galaxies because they are like a cloud, a sphere of stars.
Mm-hmm.
Another ones are like spiral ones, like that one,
Okay.
like our own galaxy. And let's zoom in again, and we have our local neighborhood.
Okay.
This is the Milky Way. This is the small Magellanic Cloud, the large Magellanic Cloud. They are satellite galaxies
Yeah,
that
okay.
are
The
orbiting
rotation, yeah, the
orbiting around Milky Way.
Yes.
Because galaxies always merge and they come like this and bunch into each other, and when they bunch, they stick around.
Kind of stick to each other.
They
Some-
stick and they keep orbiting each other, and these two galaxies are orbiting each other like this.
Yes.
They are like sisters. This is the Milky Way and the Andromeda
Oh,
galaxy.
so that's Andromeda.
And this is M33.
Okay.
Another spiral galaxy that is closer to Andromeda, that is a bit smaller. And we zoom in, and this is the Milky Way.
The Milky Way.
On the center of the Milky Way, there are star clusters, they are called. There are a lot of stars that are accumulated in a small space. Those are older, the oldest stars of the galaxy. When the stars formed, and then they start clustering in galaxies, and the star clusters are the oldest one, and they are around the center, in the top of the center and in the bottom.
Okay.
And all the galaxies that are in the arms are younger galaxies. So here in the center we have a star galaxy, a star cluster, and in one of the arms there is sun. There is our sun.
The sun is in one of the arms. Okay.
Yes. So here is the sun, and this is the nearest star from our sun, that is called Alpha Centauri system.
Okay.
There are really two stars, Proxima Centauri and Alpha Centauri, and this is the nearest star. They are 10 to the 16 meter far away.
And we started at 10 to the 27th, so we're now at 10 to the 16th
16.
for our nearest star.
Each one of these steps is like 1 or 2 orders of magnitude smaller. So if it is 100, this is 10, and this is 1.
Yes. Okay.
And this is 10 to the 16 and 10 to the 15.
Yes.
We zoom in and we see this chunk of ice rocks that I was
Which
mentioning
was here, yes.
before.
Okay.
That is that,
Yes.
and it's called the Oort cloud. The Oort cloud is surrounding. It's very big. Like the solar system is like this, and the Oort cloud is like this.
Okay.
It's surrounding the solar system. The comets come from this cloud because if this is the Oort cloud of the Milky Way, no, of the sun, the Oort cloud of the sun. This is the Oort cloud of the
I see.
Alpha
Okay.
Centauri.
Got it. Okay.
When two stars pass each other very close, they never bunch into each other because they are so small and the space is so big that they never bunch. They pass near, and the Oort clouds are the things that interact into each other. When
they create the space for them to move, the Oort clouds.
The Oort clouds interact when the stars pass nearby.
Okay.
When they interact, imagine one of these stars passing by close, and some of these rocks are affected by the gravity of the other Oort cloud, and so there is a wave like this. And some of these rocks, ice rocks, start going randomly to everywhere.
Okay.
One of these, maybe it goes to the solar system, and those are comets like
The
Halley
comets
comet.
originate from the Oort cloud.
They originate from the Oort cloud and from a passing by star that distorts our Oort cloud, and so the Halley comet started an orbit around this, and then it came back here and started periodic orbit because it was distorted by a passing nearby star.
Okay.
If we zoom in, that is the solar
We get
system,
to our solar system. Okay.
10 to the 15 meters, and we have here the big planets, giant of gas,
Yes.
and the small planets. This is not really to scale because the small planets are like very tiny and the big planets are very far away from each other. So let's zoom another time and we can see the inner solar system is called. That is only the Earth,
And the sun.
the Sun, Mercury, Venus, and Mars. This is the closest thing to the Sun.
Yes.
Another order of magnitude is the Sun, 10 to the 9 meters, and 10 times smaller is the Moon's orbit,
Okay.
the orbit of the Moon,
Yes.
and 10 times smaller is the Earth. They always show us in the graphics that the Moon is like this and the Earth is like this and they are very close. No, the Moon is very small and they are like this, far away. So they like this, very far.
Got it. Okay.
So, okay, this is the Earth, and then this is the graphic. We skip some orders of magnitude here. Maybe we should have seen first an island, and then something smaller. But okay, we don't have a space to show all the things here.
Okay.
So we skip a few orders of magnitude.
Sure.
Now we see here a human scale is really a tree scale, the scale of the tree,
10 meters.
10 meters. This is some tribute to a movie that is made here on
Yes,
Chicago that is called
I've forgotten the name already, but yes.
The power
Yes,
of
it's,
10.
I thought it was the Power of 10. Okay.
Powers of 10. Yeah. That one. Irwin have asked me to make a tribute to that movie, and maybe if I could make a picnic scene like that one on the movie.
Yes.
And so I take a picture of my brother. He's my brother.
This
and
is your family.
Yes, he's my brother and his girlfriend.
Okay.
And say,
Aw.
hey, let's make a picnic, and I take a picture of you.
That's awesome.
So we made a similar of the movie that in the movie.
And
The
this
girl
is
was reading a book and the man was taking a nap.
yes. Now, and where is this in Argentina? This is in Argentina, yes?
Yes.
Where in Argentina?
Mendoza.
In Mendoza.
But, the scenery is a free open source image that I found on the
Okay.
internet.
Understood.
The tree,
Okay.
It is from Chicago. This tree is from Chicago.
Chicago tree.
It's on the lake
Okay, yes.
because this movie was filmed on the
Yes.
lake on Chicago.
That's where it started, yes.
So
Them
I
picnicking.
wanted to use an image that was from here. So okay, it's open source image. I didn't
Nice.
stole it from any photographer.
Open source.
Open source.
You borrowed it. You used it for the purpose it was intended.
So
Very
okay.
cool. Thank you. Thank
you.
you so much.
I'm
Thank
very
you.
happy to be here and
We are very
and
happy
to-
for you to be here.
have participated in this Wonder Museum. When Cole Pershall told me it's called Wonder Museum, oh, Wonder, yes, I
Yes.
want to be in.
Cool. We are very happy to have you and your beautiful artwork. Thank you.
Okay.
Thank you for explaining it to us.
Okay,
Thank you.
you.
All right. Thank you.